Hello everybody, I am going to do a few extra examples from section 2.5 with the two-column proofs that involve both segments and angles. I am currently on page 58 of your student journal. So I would suggest that you follow along in your student journal as I go through these problems. So let's take a look at number 2. We have already done number 1 as a class. Okay, so looking at number 2, we have a two-column proof where the given statement is angle AEB is a complement of angle BEC. So I want you to remember that complementary angles add up to 90 degrees. If we look at our picture, we have AEB is right here, and then we have angle BEC right here. They are telling us that they are complements of each other. Okay, so that is our given. So statement, exactly as you see it in the given up in the beginning of the problem. The reason for that is strictly just given. Now, if an angle is a complement of another angle, that means they will add up to 90 degrees. Okay? A definition from chapter 1 is a definition of a complementary angle. This is the idea that I can state that the measure of those two angles, AED, and the measure of BEC, since they are complements of one another, they will add up to 90 degrees. The reason for that, again, is the definition of complementary angles. Complementary angles is a topic that we talked about in section 1.6, to make a note of that. Okay, the next statement states that AEC, which if you notice is this big angle here, it's a little too big, okay, here and here, okay. The angle, the measure of angle AEC is equal to the measure of angle AEB plus the measure of angle BEC. So you can see that they've taken AEB, that's this angle, and BEC, and they've added it together to get this bigger angle. When you take part of an angle plus another part, and you add it together to equal a big angle, you get what we talked about earlier in class, which is angle addition postulate. Remember, those addition postulates, both angle and segment, are this idea that we take half plus half, or not even half, but part plus part equals whole. Okay? It's possible it could be half, but it's not always the case. The next thing that they state is they state that the measure of angle AEC equals 90 degrees. Okay? So I don't see in the picture where that would come up. So if you don't see it in the picture, remember I suggested that you look in previous statements. So let's see. Here is the measure of angle AEC. And then here's where I've mentioned 90 degrees before. If you notice, both of those things equal, and I wrote the wrong letter here. Let me fix that. Whoopsies. I'm sorry about that. Make sure you fix that in step 2. That should have been a B, not a D. I think I said B, but wrote D. Anyways, so if you notice these two items here, right, they equal the same thing. If two things equal the same thing, then they are equal to one another. This is what we call the transitive property. The transitive property is always, it's like this idea that you have two statements that you're sort of squishing into one statement. Okay? All right. Next statement says the measure of angle AED, I'm going to erase some of this stuff up here. Measure of angle AED, that's this angle here, and the measure of angle AEC, that's this one here. They're saying that it equals 180 degrees. That is the definition of supplementary angles. Remember, supplementary angles, again, coming from section 1.6, is the idea that two angles add up to 180 degrees. Okay, so there is that statement there. And that's because they create a line, right? So then we have in step 6, because there's nothing to fill in for step 5, in step 6, they're using the substitution property. Okay, so let's think about what could they possibly be substituting, okay? Now, one thing that I know is my goal is my proof statement is to get this measure of angle AED by itself. So it would be really cool if I could get this to be all by itself. And I'm almost there, okay? What I do know is I know that AEC is 90 degrees. So I can substitute this 90 degrees for the measure of angle AEC. They can take the place of each other because they're equal to one another in step 4. So substitution gives me that hint that I'm going to say that the measure of angle AED plus 90 degrees, because I'm substituting 90 degrees with AEC, where AEC was because they equal each other, equals 180 degrees. Now, if I want to get AED by itself in step 7, what I would do is I would just subtract 90 on both sides. That'll allow that 90 degrees to cancel out, leaving me with 90 on the other side, on the right-hand side. So what I've done to get to step 7, which is my proof statement, is I subtracted on both sides. So that would be the subtraction property. Remember, subtraction property can be used with angles, segments, and numbers, as long as we're dealing with measurement values. Okay? All right. In number 3, it just says name the property that's the statement illustrates. So it's saying angle RST is congruent to angle TSU, and angle TSU is congruent to angle VWX. They've then stated in their conclusion that RST is congruent to VWX. And you can see that both of those things are equal to the same thing, or sorry, both of those things are congruent to the same thing, so therefore they are congruent to one another. So this would be an example of transitive property. And then in 4, we have segment GH congruent to segment JK. Therefore, their conclusion is JK is congruent to segment GH. So all they've done is they've flipped it around. So remember, when they flip it around, that is an example of the symmetric property. Symmetric property allows you to change the look of the equality or congruency statement by just flipping it around. Okay, so let's take a look at number 5. In number 5, it says write a 2-column proof. We have a given statement and we have our proof statement. Remember, a given is what you should start with. Your proof should be the very last step. They've also given us this picture over here of a line with a bunch of points on it. All right, so let's get started. Okay, so first thing we're going to write is step 1. So I'm going to number it and I'm going to write down my given. M is the midpoint, which I'm going to abbreviate midpoint of segment RT. Copying it down exactly as I see it. And I know that the reason for that is going to be that it is given to me. All right. So, the next thing that we want to think about is, what does that give us, right? Knowing that we have a midpoint, what does that tell us about our picture? if M is the midpoint of RT, right, it means that we have two segments that are congruent where M is the middle, right? So I'm going to go ahead and make the statement of the two segments that would be the same measure, or in our case, congruent, because M is a midpoint. So we have RM is going to be congruent to MT. Or you could, just write MT. I'm going to write it as MT because I have MT in the proof statement. So I want to keep that consistent. Now, the reason for this is the definition of midpoint. Okay. You could have said equals if you wanted to. That would also have worked because midpoint gives you two equal or congruent parts. I just went with congruency, and I'll deal with changing it to an equal sign later in the problem. Okay, so the reason I can say that those two segments, RM and MT, are congruent is the definition of midpoint. Doing a little abbreviating here. Step 3. Okay. In step 3, I see that, and I notice that in my proof statement, I have an equal sign. So I want to change that congruency to an equal sign. So I want to change this to RM equals MT, which we talked about is in class that this is definition of congruence. Remember, definition of congruence allows us to change a congruency symbol to an equal sign, or the other way around, an equal sign to a congruency symbol. Okay, and again, I want equals because of, well, the equal sign in the proof statement. If I had a congruency sign in my proof statement, I probably wouldn't have done step 3. So I'm going to go to step 4. Okay, next thing. I see in my proof statement, so I'm going to erase my picture here, that I have something with an RS and an SM, which I see that those two segments, RS and SM, those combine together to give me RM. And remember, when you have a part plus a part equals a whole, that is a addition postulate. And since this is segments, I'm thinking segment addition postulate, right? So I'm going to go ahead and do segment addition postulate with RM. So I'm going to say RM equals the part RS plus the other part SM. And again, that's segment addition postulate. I'm going to abbreviate postulate, P-O-S-T. All right, I'm getting closer. So I'm on to step 5. Okay. I can see that my proof statement deals with RS plus SM, but it wants it to be equal to MT. So if I look at my previous steps, I can see that here's my RS plus SM, and then here's my MT. If you notice, those two statements are equal to the same thing. Since both of those statements I've highlighted in yellow are equal to the same thing, it means that they are equal to one another. So that means RS plus SM equals MT. And that is what we call the transitive property. We've used that one a lot. Now, I'm almost there. You might be like, well, you are there, but I'm not. Okay? because I wasn't thinking, I just went ahead and wrote it down in this order. But if you look at your proof statement, it's flipped around from what I have in step 5. So if I was paying better attention, I would have just written MT equal to RS plus SM, but I didn't. But since I just gonna like leave it how it is, it's fine. I can flip this around. Remember that there is a property called the symmetric property that allows us to flip an equation statement or a congruency statement around and it still be true. And that's called the symmetric property. So I can now say that MT equals RS plus SM, and that is exactly what my proof statement is. Okay. And you might think that I was done at step 5, but I was not. Your last statement should read exactly as you see it in the proof statement. And if it does not, you either fix what you've already done or you just add more steps and give reasons for why you did what you did. Okay, so that is the end of the proof, and that is the end of this video. There is one more example that you could try on your own if you wanted to. If you go back to your student journal, the first page, I think it's page 55. So on page 55, if you wanted to try one more on your own, you could try example 4 on your own. They don't give you much to go with, but it's something that you can definitely try on your own. Or if you want help with it, please come to support time and I'd be happy to go through it with you step by step. I hope this video helps and have a great day and good luck with your practice.